guys, it's your boy Sargent back with another YouTube video, and this one's going to be a programming challenge video, so it's not really going to be like a tutorial. I will talk through what I'm doing the best I can. I'm just going to try and code a HTML5 JavaScript snake game, so let's see how this goes. So I've just got this little bit of HTML here, which is just this little web page. So we've got a score over here, and we've got the canvas itself, and then obviously we've got a script tag where we're going to refer to our JavaScript file, which is here. So disclaimer, I've looked online at different snake games, so I know roughly what I'm going to do. So let's have a little butchers. First thing we need to do is get the canvas object into our script. Get element by ID, my canvas, and you now have to have a context for these little animations. So you canvas dot get context 2D, and we, just to save ourselves a bit of hassle, we can define a constant width and height equal to the canvas width, just so that we don't have to keep writing out canvas.width. It would help if I could actually type. And we do the exact same with the height. One of these, I'm not going to make this mistake, I'm going to test and go, make sure I haven't made any syntax errors. Okay, we're all good. We're going to do the snake as a list of squares, little blocks. So let's make a list, define our first square. It's going to have an X and it's going to have a Y, and we want X and Y to be the width divided by 2, and we'll say Y 100. So that's where the first square is going to go for the snake's body. And we'll say he has 5 body parts, and each square is going to be 10 by 10. So this will be 10 down from the previous one. So it's like a row of, basically it's a downwards column of 5 squares. And then we can do, we need a velocity basically of how the snake is moving in terms of its X and Y coordinates. So we can do X and Y again. Its starting velocity for X we'll say 0, and then for Y it's 10, so it's moving down at a rate of 10. And we need to define the exact, like a starting position for where the food's going to go. So this is going to be X, we'll say height divided by 2. So just check here. Yeah, we're still good. So we've defined where our snake's going to start. We've defined the starting velocity of the snake. We've defined where the food's going to go at the start. What else do we need? We need to put in a score start at 0. That's pretty straightforward. That's pretty much everything that we need to initialize for the start of the game. But we need to have like an entry point for the program. So we'll say play, and then we'll define our main function. We'll call it play. Sorry. To use to write in Python and doing a semicolon on that. We're going to do this in a specific way that I've seen, which is the set timeout function. Set timeout basically waits a specific period of time and then executes a function, and it takes 2 parameters. the first parameter, which will go here, will be our function, and then the second parameter is the amount of time that we're going to wait, which is going to be, let's just say 35 milliseconds. That is. And then here we'll define our function that is going to, so it's going to execute what we're writing here after 35 seconds have passed. So let's call it at interval, and our interval is 35 seconds. So this is going to run now. What do we want to do at this 35-second interval? So the first thing we need to do is clear the canvas. When you make these games, you basically animate, clear canvas, animate, clear canvas. So you clear the canvas, then adjust the all the coordinates of every object, then you clear the canvas, and you adjust the clear the canvas. So the first thing we need to write is a clear canvas function, which is just going to blank out our canvas, and then we need to write a function which is going to move the snake. So change the snake's coordinates based on the velocity of the snake. So we can say, cool. You can tell that I don't write JavaScript very much. And we can do context.clearRect. So this is basically saying clear a rectangle. So take a rectangle in the coordinate grid. So, and that's defined by its x and y coordinates of its top left-hand corner, and clear everything that's inside that rectangle. For us, we want to clear everything. So we're going to say starting from 0, 0. So the top left here, blank out the whole thing. So, and we need to say how big the rectangle we want it to be, and that's fine for us. We've got our height and width defined, so we're going to clear the whole rectangle. Make sure I've got no errors. Okay, but that's fine because we're about to do the move snake function now. So this is going to work. We're going to have the snake as, well, the snake is a list of squares defined by its x and y coordinates of the top left hand point of the square. So what we can do is just add a new block to the front of the snake and chop a block off the back, and that's going to make it look like it's moving. So we need to define the head of the snake, which will have an x and y, of course. And these values we want to be equal to the snake's current x, so the front part of the snake's current x plus the velocity's x value, and we'll do the exact same, but we will do it for the y values. I think that's fine. Yeah, don't do JavaScript, mate. So we need to add this to the snake, so we can do snake.unshift head. So that's going to add that new square to the snake, and then we can do, we just want to take one off the end, don't we? So we just pop. So we get rid of one. So obviously we can't see anything on the canvas right now because we're not drawing, but these coordinates and everything are still happening in the script. But we need to draw. So because we're gonna have to draw the food as well, we can just do a draw rectangle. Square, it's gonna be a square, so we do draw square. And what we give the draw square function is we will give it one of these objects which has an x and y, and then it will take them values and go into the canvas and draw. So we're going to pass in one of them objects, and we're going to do very similar to the clear, how we were clearing a rectangle. We'll do clear, we'll do stroke rect, but we don't want to do that. We want to do square.x, square.y, and it's going to be a 10 by 10. And we want to draw the square for each part of the snake, so we can do snake dot for each raw square. And we've got our snake being drawn, but it's not actually moving right now. And that is because okay, so yeah, we only run this set timeout function once, right, which is not ideal. We want to keep repeating itself, so we can just call the play function recursively from within play, and it will run this again. Probably not the best practice to do this, but it's only a little web browser game, doesn't really matter. And then we've got a moving snake. So the next thing to introduce into the game is obviously changing the direction of the snake with the arrow keys. So we're going to have to define another thing before we play here, which is going to be our key map. And then we're going to say on key down, on key up, run a function that we'll define here, and that function is going to have an event argument, and we're going to reach into the event argument and pull out what key has been pressed, and we're going to assign the value of whether or not the key is down. So the way that we do that is we reach back into the event again, and we just get the type of event. Is it key down or a key up? Well, I'll tell you what it is, or what we're comparing it to is whether it's not a key down or not. So all this is doing is creating a map, which is basically like this. True if the key is down, and if it's not down, it's false. So we can refer to that map and find out what's going on. And just make sure that this is all good. Yeah, nothing's broken. So here we want to do the change direction, and the way that we'll do this is we just manipulate the velocities of the snake. So we can change it x and y velocity to make it change direction. So this one should be easy. And we just go here, and we just want to do, and then we do a key. We look up what keys we press in our key map. So when we just say if, it just means if that's true. X, sorry, velocity. Set our Y velocity here, and we can just do this. For each of the arrow keys, and then all we need to do is work out how we want to change the velocities based on what key's been pressed. And yeah, we just need to change these two. Right, left. So if it's arrow down, then we want the Y. The X velocity should be 0 for the down and up ones, and if it's down, then we want the Y velocity to be 10, because remember 0, 0 in the top left, and then this is the same, but that one's minus 10, and we got arrow right, so that's going to be 10, 0, that's going to be minus 10, that's going to be 0, right. So we're just saying if this key's pressed, change the velocity that way, and we need to say that. Okay, look, there we go. So we've got a snake and it's moving now. See how there though you can go like that. We've got to change that because you can't reverse in snake. It's not allowed. And what we can do here, we can do another check and basically say if the velocity of the Y, so it's basically we want to make sure that it's not trying to go the opposite way that we're changing it to. So this should be -10. So basically it's just saying check that we're not, it's that the way that they're trying to move is not the opposite of the way that it's going. Right, because that's the opposite of that. So we can just copy that and do the same for each one of these. And this one should be 10. And this one should be x and -10, and this one should be x and 10. And let's give that a try. See, I can't reverse now. I'm trying to reverse, but I can't. This is what we wanted, although it's hard to see. Let me close this. See that we can, you can hear me pressing the key trying to reverse. I can't do that anymore, so it's working as we want it to. So what's next? I guess the next thing to do is add the food. Right now we're not drawing the food, although the food does have, it is initialized with a position. And we do have a draw square, so we should just be able to, so for the first food anyway, we can just go and then we should just have a little 250 square. Yeah, that works nice. But now we need to eat the food, so that's the where we're going to do this. We can just basically compare the position of our head that we've already worked out with the position of the food. So we can do, if the snake, so at this point snake 0 is now the head, by the way, because we've just unshifted head onto the top. So we can just say equals food, and we also need to check the y value. Why does that thing, honestly, these snippets. Right, so this is our condition for the food being eaten, and if that is, then we want to increase the score, and we want to update that element of our HTML, which is the score element, equals score. This needs to go to refer to the in between the tags. Use the dot in the HTML, and okay, so right now we add one to it, and then we pop one off the bottom. If you eat the food, we just don't pop one off the bottom, and then that will keep the length of the snake how it is. Yeah, which is, and then we just leave that like that. So let's try that. So now it should eat the food. It's not eating the food though. Nothing coming up on the logs. Snakes, X position, foods, X position, snakes, Y position, no foods, Y position. What is going on here? The score's going up, so we know that it's entering that. It's getting longer as well. That's because yeah, okay, so the food's just staying there though after, which makes sense. So what we need to do now is we need to change the position of the food, and we can do that with another function, set food position. You close these up. And for the set food position, we need to generate a random number as well. and that random number needs to be between 0 and 500 because that's our grid. So the best way to do this is we need a math. So if you do math.random like this, it's going to give you a random number between 0 and 1. So we can times that by 50. And then we do a math.floor to get rid of, because it's between 0 and 1, there'll be decimals. So math.floor will bring that into a whole number, and then we can times it by 10 to bring it into the 500s. To set the food position, we just modify our food's X and Y position. And we want these to be just equal to a random number between, let's try that out. Okay, math.floor is not a function. Oh, it's a lowercase f, I think. Yeah, there we go, and that's blue. Oh. Okay, so you've seen that. It moves the food. Well, I won't play Snake all day. The next thing we can do, if the snake just goes straight out of the wall, we need to check for collisions. So we can do another function, detect collision, and this one's pretty straightforward really. We just need to check each wall. So we can say left collision equals, and then we just look at the value of the snake's. If it's left, then we're talking about the x value, so we need to look at the snake's x value. And if it's less than 0, because remember 0 is on the left, like there. And we can just do this for each one. Right. We can just say here, if it's greater than the width, and then for the top and bottom it's going to be y. They can stay the exact same, but this one turns it around, and then we're just talking about the height. And all we want to do is return if any of these are true, so we can use OR for that. Just do left, or right, or top, these snippets, or bottom. So that would enable us to know if the snake's come into contact with a wall, but we need to come back to here and just check if that's true. Because this play function gets called recursively, we can just check at the top. So we can just say if detect collision, and then we just return, which will break out of this function execution. Okay, something's gone wrong. Okay. And then you see it stopped. So that's the basic game really. It's 23 minutes in the video, so I said I was going to do a longer video, so what else can we add? We only check for collisions with a wall, so we can do something here to also check for collisions with the snake's own tail. So let's do a loop. We're saying for, and then we'll say for, and the reason we say for is because the snake's got 5 body parts and it's 0 indexed, so it's 0, 1, 2, 3, 4. So we don't want to check for the initial body, right? Because that would be stupid. So while I is length, my typing is terrible on YouTube. It's not normally this bad. So we're just going to loop from 4 to the maximum, the very end part of the snake. So we're just going to check each body part of the snake which wasn't part of the initial body, basically. Snake. Check the X. If the X is equal, so that if the X of the new body part is equal to the position of the snake's head, which we know is the 0, that means that it's collided with itself, but it also needs to be the same in the Y. So that's our condition now. The snake's head, it's like the food. The snake's head's in the same position as the food. Here, the snake's head is in the same position in one of its tail blocks. Then we run this, and we just do return true, because that's what's going to trigger that Boolean expression up here, and then end the game. So let's try that. Need to build a little snake up just to right. And now I've collided with my own tail. So I think that basically covers it. We're on 26 minutes. Oh, maybe what else can I do? I want to do half an hour video. One thing is that the food, because it goes anywhere on the grid, the food could also randomly spawn where the snake is. There's a small chance of that happening, which is obviously not supposed to happen in the game. So we could add a conditional statement here saying if, so we need to check each body part of the snake's X and Y values to see if it's the same as the new food position. If it is, then we need to change that. So we can say for each and then we write a function inside here and we'll say fs collision, food snake collision, pass it a square, and then we can say check food's X position against the position of the snake's body part at that point. And if that does happen, then all we want to do is set the food position again. And that should do it, I think. So basically that just means that the food will never spawn where the snake is, which is what we want to happen. I mean, there's not really any way for me to demonstrate that's going on, but it's just like, my god, I'm bad at snake. There we go. That's it. That's a programming challenge complete. Hopefully you enjoyed watching me go through that. Snake is pretty basic. I don't know what the next programming challenge is. Hopefully something that isn't JavaScript, because it's not my favourite. Hope you enjoyed the video, and hopefully I'll see you next time.